I think that's working. The stream has started. I'm waiting for the preview to show up in YouTube. But I think we're going. Hey. There you go. Figure it out. There we go. Good afternoon, everybody. It is 2:42 in the afternoon on the Pacific coast of California. Today is Tuesday, October 3rd, 2023. My name is Mark, a.k.a. Smitty. Today I will be working on the open source version of a user adapter for OHIS, the Open Headset Interconnect Standard. If you want to learn more about the Open Headset Interconnect Standard or what that is or why we're doing it, go to ohis.org. There is a video there where I talk about what problem it's trying to solve and why we want to do it. My company, Halibut Electronics, sells commercial versions of these things, and I have them in stock now. Here is a example of the user adapter product that I sell. This is a fancy schmancy version in a case with built-in VU meter and all kinds of other excuse me, snazzy features that can be configured for just about any type of headset out there. But if for the open standard to be truly adopted, we also need to make sure that there are open versions of it. And I keep saying that I want to encourage people to DIY these things and build their own and all that fun stuff. So to that end, I want to make an open source version of this and make it available as part of the standard. Excuse me. That open source version, the code, the link to that code is available in the description below. It's a GitHub link. You can follow along with what we're doing there. But right now, we've got KiCad open. So that's what we're going to do. This is the schematic. It's pretty simple. Here is a board outline or a component that I made that's just a copy of the RJ45 outline, but I modified it so that the pin numbers, the pins have the labels for what signals are on those pins in the OHIS standard. Dang it. My throat is feeling tickled. So that's just a component I made that makes it easy to lay out OHIS stuff. So those are all my flags over there. And this is going to be a very simple user adapter. So the OHS on one side, and then a 3.5 millimeter headphone socket on the other side, a 3.5 millimeter microphone socket, and then a 3.5 millimeter PTT socket. So that's what's on the other side. Then there will be some jumpers that you can use to configure whether headphones are just standard 3-pin TRS headphones, or whether it is a 4-pin CTIA style, like the TRRS, the 4-pin connector that is common on PCs now, used to be common on laptops, on mobile phones. It's called the CTIA standard, but I sometimes call it the PC gaming headset standard. Anyway, it is tip is left, the first ring is right, the second ring is ground and shield, and then the sleeve, the fourth connector, is the mic plus. And then all the headphones and the microphone share a ground. So this jumper right here, the only thing that changes is the sleeve connection, whether the sleeve is connected to the headphone ground, if this is just a normal headphone, or if it's connected to mic plus, if this is a CTIA headset adapter. So you move a jumper from 4 to 2 for a normal headphones and it connects it to ground, or 4 and 6 to connect it to a microphone. And then the jumper on the other side as well, just headphone ground and headphone ground. That's a dummy position just to hold it. But when it's down here, you also have to tie mic ground to the headphone ground because they are on the same signal. So putting two jumpers on here up in the top area sets it up for just a normal headphone, or in the bottom area sets it up for a CTIA style headset. Then the microphone is pretty simple, just mic plus and mic minus. And PTT, again, is simple, just PTT and ground. There is also a PTT on the device itself, so there will be, you can hold the device in your hand as the PTT trigger, and then just a debouncing cap. And then the last bit of quote-unquote complexity here is that if you've got an electret microphone plugged in over here, then you just want the microphone signal to go straight through to the OHIS. So this is mic plus 3.5, meaning the 3.5 millimeter socket, and then mic plus on the OHIS is over here. So if this is an electret microphone, then you just want it to go straight through, and so you put a jumper across from 3 to 4. And then 1 and 2, you would put a jumper across just to hold it there. However, if this is a dynamic microphone, then we need to put this very simple dynamic microphone amplifier in line with the circuit. So you rotate those jumpers so that they go vertically, and now the microphone coming in from the 3.5 millimeter socket gets all of the DC blocked, so no DC goes into the microphone element. That audio goes into this amplifier, and then the output of the amplifier goes into the mic plus of the OHIS signal. This is a schematic or a circuit that is included as part of the OHIS standard that is available to anyone to use. It's not required, but you're welcome to use it. It uses the DC bias voltage coming from the OHIS radio side that's part of the electret microphone standard. It uses that DC bias voltage to power the amplifier here. So it doesn't actually require the VCC power coming in here. Anyway, so that is a microphone preamp that you can plug a dynamic microphone into, and then it looks like an electret microphone upstream. And then that's it, and then mounting holes. So that is the user adapter that we're going to do. So this user adapter, assuming you can connect your stuff into a 3.5 millimeter headphones, a 3.5 millimeter microphone, and a 3.5 millimeter PTT, or use the built-in PTT. As long as you can get the connectors to work into that, then this will work on either like two-plug, like a Heil headset, where you've got a separate headphone and a microphone, or a single CTIA, like a PC gaming headset, the 4-pin stuff, whether it's a dynamic or an electret mic, all of that to work with OHIS. Pretty snazzy. And very simple, right? This is going to be a very simple, very low-cost kit. It's open source. Anyone can take this design and modify it and use it for however they want, or build it straight as it is. I will be selling these as kits. I'm going to sell these as a through-hole kit. Apparently I've got a repeater on. I will be selling these as a through-hole kit that people can buy from me and then assemble themselves. So let's bring up the board. I worked on this on the previous episode of this live stream series. And what we have here is, this is the OHIS socket on one side, so that's the RJ45. And this is the PTT line coming across. And so here's our 1 nanofarad capacitor. That's our debouncing cap that goes into the button that is on the board itself, and then into the 3.5 millimeter socket. This whole thing is kind of long and skinny. It's meant to be held in your hand like a hand trigger, kind of the same way that these are. This is my commercial product. You just hold it in your hand, and then you've got the button right there that is easy to press as a PTT. And so when you're holding this, the OHIS comes out one side and the headset comes out the other. There has been suggestions that I modify this so that all the cables come out one side, and the PTT is just, there's nothing out the top here. So all the cables come out one side. I am not sure how I feel about that, because that would make the whole thing much wider. I may spend a little bit of time looking at that. I kind of like the idea of having a long, skinny, handheld button thing. So that's the reason I designed it the way I have so far. But anyway, so that's the PTT that goes up there. Here is the mic preamp circuit. There's a transistor, 3 resistors, and a capacitor. It shows 2 capacitors in parallel on the schematic, just so that I can have 2 different size pin spacings. Right? It's just a matter of what pin space, what size capacitor you have. There's the 2x2 jumper where if they are, let's see here, if they are horizontal, then it will bypass the mic circuit. You do that for an electric microphone. If they are vertical, then it will put the mic circuit, the mic preamp in circuit. It will not bypass it, and that is what you want to do if you're using a dynamic mic. And then here is the CTIA or normal headphone jumper block. And then let's see here. So this is the microphone connector, and this is the headphone connector here. Now you'll notice that I've got these kind of weird ground plane sections. So up top, the PTT is normal power ground, but mic ground and headphone ground, I want to try and keep them separate as long as possible. So all of this here is mic ground or mic minus. I guess those are the only two places that have it. But by making the ground pour around all of this circuit, it makes it all reference to that ground. It should be the same, like voltage-wise, as this ground, but I like keeping the currents isolated so that the return current from the PTT isn't going underneath this circuit, because then any noise that gets picked up in the PTT circuit will show up in the ground here, and weird things happen. It's better to keep it isolated for as long as you can, as much as you can. And then so the mic ground comes along in here and connects to the mic connector, but because of the jumper, it might also come around here and connect to the shield of the headphone connectors, because that's how we make it a CTIA, the 4-pin TRRS stuff. So the mic ground kind of comes around here, whereas the headphone ground comes around and is isolating, is surrounding my headphone left and headphone right signals. And it comes around and connects to the ring 2 there. So that is where I got to last time. I wish I knew a way to get this to default to my stupid American Freedom units every time I start up the app, but I haven't figured that out yet. Manum, doop doo 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 doo. Okay. So, oh yeah, that ground lug is isolated from that ground as well, because I may want to just end up disconnecting that one and not connecting it to a ground. Okay. So that's what that little rat's nest right there is telling me. There's a white line between that ground, because that's a mounting hole, and it wants to be connected to power ground. Now, in theory, I could connect it to microphone ground or headphone ground, but if you ever mounted this to something with a metal, a metal standoff or a metal screw here that connected that to this, and this was a different ground, you would end up shorting those grounds together if you don't need to. And so I'd rather not, I'd rather not do that. So instead, I'm going to take H2 and I'm going to disconnect it. I'm just going to make it not connected to anything. Okay. Update from there, close, and boom. Redraw my things. Yep, that's what it's going to do. Okay. I think I'm okay with that. We'll just do that. All right. And put some vias in here to connect these up. Bloop. Okay. So now what do I need to do? I need to get mic ground, which is this pour, to that pin right there. Get rid of the via. I need to get mic plus to that pin. Then I need to get headphone left, headphone ground, and headphone right down here. Yikes. Okay. We'll go to headphone ground. This is not going to go well, I don't think. Well, let's see what happens. Yeah. No. So that pin is where I'm getting my headphone ground, and you can see it kind of creates it over there. But I would have to... Yeah, shoot. All right. I would have to bring it all the way around here to get it to connect up to this, but that's going to cut this ground off, the power ground, from the rest of it. So we're just going to have to do a big old fat trace. Do I have any? Nope, I don't. So let's make a big old fat trace, 0.030 inches. Okay, so let's try that. So how this is different is that this is only going to be disconnecting on the top layer, not on the bottom layer. So power ground will still connect through on the bottom layer. I am not a huge fan of this. Let's see what this looks like, though. Create corner, and we'll do another one here. Actually, let's just do that. Oh, nope, can't do that because that cuts off our ground. There we go. I specifically need this to go around this ground pin so that the ground pin can stay connected to the bottom layer. 3 edges. Keep PTT headset and mic ground currents separate to reduce interference. Yes. Oh, got it. Emmet was asking why 2 grounds, and Nerd Garage responds 3. That is correct. So, because if ground were literally 0 ohms, then everything can use the same ground. And if you go to great lengths to make sure all of your grounds are as low impedance as possible, then it doesn't much matter. No ground is actually 0 ohms. And so when you have a little bit of impedance, and if that impedance is in series with your ground, then you're sending current out the transmission line to whatever it is on the other side, whether it's a microphone or a headphone or a speaker or an LED, whatever it is. You got some current that's going out. That return current has to come back some way, right? And that return current comes back through your ground. Now, if you're sharing the return currents between your headphones and your microphone, right, that means that your headphone current is coming in the same ground that your microphone is using. If that ground is 0 ohms, then whatever current goes through there results in a 0 volt drop, doesn't matter. But if that ground is, say, 0.1 ohms, that's pretty high. Generally, they're going to be like 0.01 or something like that, but let's say it's 0.1, and you've got 10 milliamps coming in through your headphones coming in there, right? 0.1 volt times 10 milliamps, that's going to be 1 millivolt induced across that ground. That did I do that right? V equals IR. Let's say we got 10 milliamps of return current from our headphones, and of course that 10 milliamps varies with the audio, right? We'll say peak of 10 milliamps, and it's a 0.1, so it's going to be 1/10 of 10 milliamps. It would be 1 millivolt. Yes. So now I've got a 1 millivolt peak-to-peak signal being added to that ground. So that ground point from where they split out between headphones and microphone is moving up and down by 1 millivolt. 1 millivolt. 1 millivolt is a lot of signal on a microphone line, right? So because the headphones are passing much more current than the microphone signal is, you really want to keep those grounds separate so that the return currents from the higher powered signal doesn't crosstalk into the lower powered signal. So ideally, we want to keep our headphone grounds and our microphone grounds as separate as humanly possible. We can't do that with CTIA headphones. So let's go back over here. The CTIA standard is headphone left, headphone right, a shared ground, and then mic plus. So the headphone left and right and the microphone all use the same return ground. And so it's just unavoidable with that connector. That's a part of the connector. It's the standard. It's what we do. But OHIS has done everything it can to keep those grounds as separate as possible, because we know that there is no truly 0 ohms in here unless we're making our cables out of superconductors. Now, good cable is going to have pretty darn close to 0 ohms, and so we can hand wave it and we can get away with a lot of things. But if you've got enough wires to keep them separate, it's best that you do. And then the reason you want to keep power ground separate, because you think it's going to be like a DC current, right? And if you're just doing LEDs and whatnot, it will be. But let's say you're powering a microcontroller on the other side. Now that microcontroller has an internal clock, and that clock is going to cause lots of fluctuations in the current draw. And that current draw is going to cause, or that fluctuating current draw is going to cause noise on your ground line, the same that the headphones did. So really, it's best to keep all your grounds as separate as possible and have them all come back to the ground terminal at your power supply, and keep them as separate as possible until they all come back to one spot that defines your 0 point. So OHIS attempts to do that, and then we are going to attempt to preserve that on this board. Does that answer your question, Emra? Sorry if I'm mispronouncing your name. Emra Ahmet. So tell me if that answers your question, please. Oakley dokley. Let's go in here and... Okay. Which one is that? Oh, of course they're crossed over. Okay. Of course they are. But we can do this. We gotta go to the bottom layer anyway, so that we can let mic plus pass through. So we'll do that here, go up to there, and then go back and do that. Okay. Okay. Oh, shoot. Oh, man. I really did not make this easy, did I? So now I want to... Yeah, we can bring this down. I want to make enough space that we still have... I want to leave enough space for vias. So let me put the vias in now. Bugger. Okay. You gonna let me get away with that? Yeah, it looks like you will. Okay. All right. So Nerd Garage is giving me a hard time for laying out, picking the pins on this 45, RJ45 in the way I did. So I usually make it a point of doing this to give credit where credit is due. But this time it's going to sound like I'm throwing someone else under the bus. I did not actually lay out that 45. And I am not intending to throw Tom Tendon under the bus, but it's certainly what it's going to sound like I'm doing. I do like the fact that all the grounds are on the backside, though, because if you don't care about that and you're willing to just tie them all together, then all of these are a single... excuse me, are a single node. Honestly, I would... KC1AWV Steve says, if those vias aren't evenly spaced, my OCD will start to... Yeah, they're not evenly spaced. Sorry, Steve. If I were to do this, I would probably put the mic on the outside pair here and put the headphones in the 4 in the middle, and then probably pair it with PTT and then put power and ground on a pair out here. But I did kind of inherit this pinout from a previous document that yeah, I made some other changes from this previous document, so maybe I should have gone ahead and made that different, but here we are. Oh, whoops. Nope. Set that. What are you doing? There we go. Mic minus. Okay, so That will get me this. Whoop, whoop. Use track net class. That is not the track net class. 0.015. Board setup. Net classes. Clearance. Track width 15. So why? That is not. That is still not. Okay. Don't make me do this the hard way. Oops. Force it to 15. There we go. There were some vias, some unevenly spaced vias. Twitch, twitch, twitch. We'll at least do that. I'm killing you here, Steve. Sorry about that. Sorry, not sorry. Oh, when I go to the larger grid size, they don't line up right. All right. Now I need to get that one around. I think I need to go green on this one. Now we see the reason we don't use such small grids. I try to default to a 0.025 grid. And then I go down to a 0.005 grid when I need fine control to move things like spacing these vias. I've only got space to put one via between. There's the 0.025 grid and there's the other 0.025 grid, but the via needs to be right in the middle of it. So I try to use the bigger grid most of the time, and then only go to the smaller grid when I really need. Oh, nuts. You're joking. Well, that ain't gonna fit. Let's see if I can make this one fit. Yep, that one fits. Okay. Whoa! No, don't move the whole thing. Just grab the corner. There were two corners there. Fine. Okay. Doesn't matter. It's not going to do anything. Fill that in. Okay. So Nerd Garage is saying that it's the insanely tiny grid that's annoying him. Keep in mind that right now, gotcha. Okay, so yes, this is a 25 mil. Right now I'm using a 25 mil. I have to go down to a 5 mil to get these into their spots. It's a little bit easier to see when you do it here, right? So this is a 5 mil grid, and I don't think of it as mils. I think it is 0.005 inches, which is 5 mils. It's the same. Yes, I know. But to get those into the right spot, that's what I do there. Let's see here. You do not have to come really. You do not have to come straight out. You can go up there and give us some more. Oh, bloody hell! Stupid grids. Oh, hey, look. It happened to land on the right grid anyway. Okay. So let's via some things. I mean, not that you really need to via stitch a GPIO signal, but why not? Good enough. Okay. Okay, so that gives me more vertical space. What I'm trying to do is I'm trying to bring the PTT in from the edge of the board. And to do that, I need to move all of that down. But what I can't do is compress. You know what? I bet I can get that jumper down some too. Okay. So let's add that to the selection. And we're going to do that. And moving down by 2 should do it for us. Okay, let me do that. Okay. And get rid of that. And create a corner. No, break track. Different terms for the same idea. There we go. Yep. All right. What is that going to do to our grounds? Oh. It's not too close. Arguably, yes. Okay. All right. So now I can grab this and move it down. Nope. Move that down by 2. Move that down by 2. All right. All right. So now I've got space to put a row of vias up there too. Yeah, I don't like that as encroaching as it was. There. Okay. All right. Via stitch all the things. That is too many. We don't need that many vias. But, you know, they're cheap. Okay. So, let's look at this thing from on high. What do we see? I got a lot of silkscreen work that still needs to be done. I should probably move that jumper to the right some, space it out from the button. Nerd Garage says there's no such thing as too many vias. I have been threatened by a board fab house to start charging for vias, but we're nowhere. Excuse me, we're nowhere near that level right now. Shoot. Okay. All right. Comments from the peanut gallery. Y'all have anything that you're looking at going, gee, I wish it did this differently? Or, hey, that is ugly. You should do that. Blah, blah, blah. Let's do front assembly view. All right. Throw your comments in the chat room while I make some cleanups on the silk screen. Because no one needs reference designators on their mount holes. Oh. That's what we were going to do. Oh. Oh, shoot. Okay. That's right. Those are ground planes we got there, aren't they? Knock it off. What are you... Seriously? I did that on a wacky grid? Apparently I did. Okay, fine. Steve asks, well, if you're asking for features, can we add the coffee maker to it? The coffee mate adapter? Sorry, my friend. This is meant to be inexpensive. So you're going to have to buy your own V60. I thought there was a way to merge those two. I can group them, but that's not what I want. Create from... Oh. No. I don't know what that's going to do, but only the finest Spaceballs references from me. Wish I could make coffee. Oh, man. It's been too long since I've seen Spaceballs. I feel inadequate. I don't get that reference. Dang, now you're making me feel bad, man. I mean, not that you've done anything wrong, just that I can't remember a Spaceballs reference. I always drink coffee when watching Radar. Only one man dares give me the raspberry. Okay. DRC. Design rules check. Run DRC. All right. Silkscreen overlap. Line on front silkscreen. Yeah. Yeah. I don't care about silkscreen overlap, so I'll clean up the silkscreen in a bit. Silkscreen clipped by solder mask. Yes, I know. Thermal relief connected to zone incomplete. Where? That one. Zone mic minus and plated through hole pad 5 of J6. Are you saying it's incomplete because it needs 2? You know what? Fine. We'll do it this way. Edit. Pad connection will make you a solid. Bloop. So we'll rerun the DRC. Silk screen overlap. Yeah. Clipped by solder mask. Yeah. Clipped by board edge. Yeah. Courtyards overlap. That's something I want to... Oh, yep. That is also to be expected. So it's saying that I have components that are overlapping, but that's intentional. Okay. So silkscreen overlaps. That's like the... Yeah, okay. Let me clean up the references, and then we'll try to come back to this. Oh, nope, not that one. That one. Aye, that one. Oh. So I've already cutting this ground under bottom with the PTT wire. I can do the same thing with a ground wire here. And then once I've got it here, I can cut it to get to that one. Might be onto something here, but for now, let me do this. Actually, you know what? Hold on. Let's make you a 30. Which means, nope, I need to pull you back. Okay. And then... that one was H2. That's the one I removed the ground from. Okay, you now think you're connected to ground. There we go. Let's do that. And then now I want, if I may, to bind that there and bind that. Oh, shoot. All right, we'll do that there. Dang, seriously? That is the only... Because it's too close to that. That's not... Shoot. So that is the only path for my headphone ground, that little bit of red copper right there. Kenneth Bingham. Hey, Kenneth, long time no chat. I'm imagining a USB HID implementation of the radio side of OHIS that would send a configurable keystroke when the PTT is closed that could be consumed by the OS or a conferencing app to unmute. So a USB OHIS radio adapter and user adapter are on my list of things that I want to design. And yes, it would let you use any radio headset with the PC. That is exactly what it would do. It would also let. It would also be useful for things like Echolink, if you want to use your headset on Echolink on the computer, that kind of thing. However, the USB keystroke, yeah, I guess some things would do PTT through keystrokes. A lot of the radio interfaces either use a serial ports DTR or CTR pin, or, depending on the USB sound chip you use, I think it's a CM108. Don't quote me, it's C something 108. I can't remember what that second letter is. There is a GPIO pin on that chip that is used as a PTT and a COR. Actually, there are a couple of GPIOs that are commonly used if you're building repeater controllers where you're using the PC as the repeater controller and then this is a sound interface to it. There are some GPIO pins that a lot of code is written to use. So if you don't want to do any USB shenanigans, then you can just use a single USB chip. This, I think it's a CM108. You get audio in and out of it and the GPIO pins for PTT. To do a keystroke or to do a serial port, you would have to either have a single device that does both the serial or keyboard and sound, or you put a USB hub on there and then split it out into the two different chips, like an FTDI for the serial port and the CM108 for the sound. So it gets more complex when you do that. So the first version I was going to do, at least, was to use those GPIO pins on the CM108. From pin 2, then 45 into the mount hole would be a smooth extension of the ground line. Because when you're doing 45s over this, it gives you less space for... but I see your point because that will allow me to use that for ground. Okay, so Nerd Garage is pointing out the stupidity in my way of running that there, which is what's causing this problem of not being able to get a good solid ground across. If I were to instead do this, then I can... hopefully, and then I can even grab these and pull them back like that, except I'm going to move that out of the way, and I am going to go back up to my larger grid. Yeah, you go out of the way as well. So now I can go to the smaller grid again, put my via there, put my via there, put my via there. Oh! Okay. So what we actually want to do now is we want to move that ground even farther this way. Or we can do that. Because now I can stick a via right there. And now we've got that additional path. So it's not just that one ground path. We've got a second one there. Okay. I like that. Is that more what you had in mind, Nerd Garage? Yeah. Yeah. He says, mostly, yes, that explains it, but it took him a while to understand why I bulged it out. I bulged it out to the right so that I have a space to put this via right here to connect this ground to that corner theirs. Because otherwise, we still only have that one little path, right? The whole point is to connect this part up to here and create a second attachment point for that ground. I can't really push these up any higher because they're bumping into these, which I can't move. I don't have enough space to have them go over, and I don't have enough space for them to go under. I don't really want to move the holes because they're all evenly spaced, and I want to keep them evenly spaced. So I think I like that. Okay. All right, so let's go back to the assembly view, front assembly view, and start moving around these. Shoot, group. Really? I can't enter the group? Okay, fine. Reference C1. We'll just call it C1, and then I'm going to hide C2. Okay. Jumper 5. These go down here. I'm going to leave the resistors. Man, no. There we go. All right. Now, what is that? That's a 040406. Okay. So text. Nope, just kidding. Front silk. Text. 040. Okay. PTT. No, I'm not going to do that one. What is we? It's 1 nanofarad. So one of my things is that I like putting component values on the board to make it easier to assemble. 27K. So some of my designs, I'll even completely remove the I'll completely remove the reference designators and just put values on there. Uh, 75K is over here, and then 470R. We'll do it this way. C1 is 1 microfarad, right? Okay. All right. Now, let's go for some bigger text. So those are all 4s. Let's go 606 1. Shoot. Oh, I am going to have to do that differently. Okay. Center it and top align it, and we'll do that. So your J. There we go. All right. Now, will there be an HTML bill of materials along with the schematic? Yeah, probably. It'll come out by default as a CSV. From KiCad. So let's see here. There we go. So there is a BOM bill of materials generation tool. BOM Manager is something that I wrote for some other things that I've got, but we can just do that, and it will generate. Excuse me. It'll generate a bill of materials in a CSV format, and that will be included in the thing, source code, GitHub. The reason I hesitate to convert that into anything else is because it's not automatic. The bill of materials generation script here is automatic. If I make a change on the schematic, that will automatically get represented when I update the bill of materials. Anything that's HTML based, I would either have to write a script to convert it and generate it into, take the CSV in and create some pretty HTML out of it, or something else. I guess it's called interactive bill of materials. I'm not sure what you mean by an interactive bill of materials. Now, having said that, the bill of materials on this is going to be the boards from your favorite board house, these sockets and these buttons are attainable. It's a KiCad plugin. Oh, interesting. Yeah, I guess I'll look into it. I'm not familiar with that particular plugin or what it does. So interactive bill of materials, interactive BOM is a KiCad plugin. I'll go take a look at it. I have no idea what it does, though. Anyway, a lot of these parts are from like eBay. These sockets, I buy 100 at a time from eBay for just a few dollars. These buttons are, you can get them 10 at a time or 100 at a time for pennies. The pin headers, I get 40 by 1 pin headers, and then I break them down. You can break off 3 at a time and put 2 of those side by side to make a 2 by 3. And again, those are pennies. Resistors and transistors, if you don't already have them in your junk pile, you can buy those from Mauser or from a sample pack in eBay or something like that. 1 nanofarad is also known as a 0.001 microfarad or 1,000 picofarad. They're all the same, and these are all low voltage. Nothing needs to be a high voltage cap or anything. And then that socket, I got a bag of these RJ45s for, again, very cheap on eBay, but you can also get them on Mauser and whatnot. I think, did I start putting? I have not. Okay, so what I can do is I can add columns to the bill of materials in KiCad and include like links to Mauser, links to eBay, where to get those parts, and then when you export the CSV bill of materials, great gravy, then that'll show up in there. Okay. All right, so we're still gonna, let's rerun DRC. That number should go down from 35 to 1. Sweet. What is my one error? Courtyards overlap. Yep, I know those two capacitors are going to overlap, so I'm going to exclude that particular exclude violation. Thank you. That's the word I was looking for. Warnings. Yeah, a bunch of silk screens are getting clipped because they're hanging off the edge of the board, and silk screens overlap. I'm okay with that. These are all the same thing as what we saw before. Steve Miller says he tagged me for a link example. Linked example is of interactive bill of materials in Discord. I will take a look at that later. Which Discord? Oh, did you DM it to me? Nope, that is somebody else. Mark on red so I don't lose that. And you apparently did it on the M17. Yes, you did. Perfect. I see you on M17. Thank you. I just put together that call sign and that name. All right, cool. Thank you, Steve. Now I know who you are. I went to college with a guy named Steve Miller locally, and then, of course, there's Steve Miller Band. But there appear to be a lot of you Steve Millers. Silk screen clipped by solder mask. Oh, yeah. Yeah. I know. By board edge, too. No, don't care about that. Don't care. Yep, all right. I'm happy with my DRC. That ID change threw me, too. Who is this guy? Okay. Front, go back. Nope. There we go. So, I do need to add some silk screen here. Edit. Let's do that. Rotation is 0. Phones. Oh. CTIA. Okay. So the question is that sufficient to understand that when jumpers are up here, it's configured for CTIA, and when jumpers are down here, it's configured for headphones? Okay. And then we got to do the same over here. Sir. Front silk. Nerd Garage just said that he just realized that I probably don't associate him with his call sign or name either. That's true. I am absolutely horrendous with names and even worse with call signs. And I just ran across your tiny circuit board that you gave me the other day when I was looking for something else up on my shelf. So, yeah, I haven't done anything with it, but yeah, I do remember that. Okay, so and let's edit this and do no, not that one. That one because they're bigger. So electret, and then oh shoot, electret is straight across, so we'll do that. And then does that work for you guys? Does that make sense? That if the jumpers are horizontal like that, then it's configured for an electret, and if they're configured like that, it's for a dynamic. Let me make it more obvious that those are jumpers. Space the lines a bit more. I'm actually going to make them rectangles. I can fill that shape, can't I? Yes, I can. That works. So like that, and that, and that, and that, and do, just like that. Does that look good? And then, actually, I think I want to do something similar up here. Oh. Like that. And then I'm going to make the same change to this one. And put that there. Huh. That's not square. Seriously? Because I'm anal. Whoa! No. That is unhappy. That didn't rotate well, did it? It's going to do the same thing, isn't it? Yep. Yep. Okay. Yeah. I'm polishing a turd here. That's fine. Yeah. I think that works. Okay. So, 3D viewer. That's what the board looks like. Since I laid out these outlines, I never did a 3D model for them. But that is the board. And of course, we've got to throw some pretty OHIS. Oh, ha ha ha! Artwork. We'll come over here. Seriously? Aye. And I've got an OHIS logo. Look at that. But I think I want that there, but that's going to be in the way of that text. Okay, so There we go. I'm going to move that J5 out of the way and put mic type underneath it. Yeah, not loving that, but and then where's my OHIS? There it is. Yoink. All right. Any other thoughts or comments on this? I am probably going to sell this as a kit. I know what I need to do. I need to turn on user drawings and go on to user drawings and make some measurements. Between the mount holes, you think? Like that? Not closer to the socket? Eh. 3.5 inches that way. 1.1 inches that way. And we're going to do this dimension and that dimension. Yeah, sure. Why not? I need more artwork on the bottom. Okay. So back assembly view. And flip our board view so we can see it in the correct order. And I want to go back to silkscreen and text and do oops, not that one. Back silkscreen. There we go. Oh, seriously? Come on. Reverse. There it is. Okay. Ooh. we don't have the space on the bottom of the board. All right. Let's make this a little bit smaller. Let's see, where does this go? So github.com, open headset interconnect standard because somebody else has the OHIS username and won't give it up. Ask me how I know. User adapter. All right, so Paxel screen reverse. Is that going to work? Can I squeeze it in there? Hot damn, I can. Then the question is there a better way to get, like, put a QR code? Put a QR code on there. I don't want to go through the trouble of generating a QR code elsewhere and importing it. Tools. Clean up tracks. Is anyone in the chat room familiar with a KiCad plugin that will generate QR codes? KiCad 7 plugin QR code. Using QR codes and KiCad info. Add a QR code to your KiCad design. Step 1, generate the QR code using this free QR code generator. Image converter and paste into PCB. Okay. Yeah. That's what I thought. All right. It's not my preference, but let's see what we got. Oh. Okay. So since I'm not doing this off the screen, let me bring this down. So this is the free QR code generator that was linked to from the site I just Googled, and it lets me upload a logo. This I want off the screen. So where are we going? We're going to go here, then here, then here. Okay, now you can be back on the screen. OHIS logo. This is the GitHub for the logo. Do you know how to do the SVG? It's awfully wee. Oh, nope, that's too much. That's not what we wanted. There we go. That's not going to show up. That's going to be way too small. All right. No logo, just give me the QR code. All right. Let's save a ping of this. Okay, so actually not there. User adapter. Excuse me. Okay, let's see what that does. So over here, we've got the image converter. I don't use this often. Load source image. Nope. That is a source image, all right. Okay. That's awfully large. Can I make that smaller? Front silk screen. So we'll make that export to clipboard. Oh! That may make this a bit easier. Whoa. Stop it. What did I just do? Hey, look. Get rid of that. Hey, all. Anybody want to try and scan that and see whether it scans? Yeah, Katie9KCK says, I'm going to be trying to adapt all of my radios and things I build to OHIS. That's the idea, right? The idea being that the more people we get doing this, then the more adoption we get. Yeah, it scans on my phone too. Okay. I'd like to put it in a space that has fewer vias. So maybe yeah. You know what? Never mind. I'll just leave it there. Okay. Yeah. Cool. All right. Flip that back to the front view. Front assembly. Then back assembly. Anything else I should be putting on here? All layers. Let's do that. Generate my JLC PCB files. Bring that down here. Okay. Add a Gerber file. OHIS User Adapter. Production Gerber. Yep, blue because I am me. Let's do 50 of these. That seems like a good fit first run. 14 quid for 50 boards. Their viewer. Oh, at least they don't make me select a thing anymore. Test points would probably be a good thing to add here too. There's a logo for the CC BY stuff, isn't there? Oh. In fact, yeah, when I did that graphic, open hardware. There are arrows? Do not look into laser with remaining eye. Huh, okay. I don't know that open hardware is the same thing. Yeah, I saw the Easter. Yeah, Radman's like, Easter egg? Oh, you are live. Yes, I am. Hello. Yeah. There's an Easter egg. Who knew? And that's what it looks like on the board itself. What? Yeah, there's a story behind that, and I don't know what it is. Oh, hey, look, there's a data sheet. That would be a language I don't understand. Looks German? That's a lot of German text I don't understand. No pictures, huh? Yeah, no idea. Okay, so there's an Easter egg in the KiCad libraries now. Oh, those don't even have footprints anyway. So these are just schematic outlines. They're not even... Okay, forget it. OHIS is going to be enough for now. All right. I'm not going to order boards right now because I also want to design another board. Oh, my gosh. I also want to design another board that goes on top of this to make a sandwich. And possibly also make one that's a third one to go underneath it, so it's like a club sandwich. I don't know, because these are all through-hole components, and so they're going to poke out the bottom. And if you hold it in your hand, it's going to be a little painful. I may also do a version of this that will work with surface mount components instead of through hole, or maybe in addition to. I've had bad luck with doing that on the sockets, though. So I'll probably make one that is also surface mount, so that you can just have the two boards and keep it super thin. But point being that it is 4:30 and I need to wrap up because I got a meeting at 5 o'clock and I should probably get some dinner before I do that. Yeah, SMT is easier for sure for some people, Radman. A lot of people have said, oh God, please not surface mount, keep it to through hole. And for an open source project like this, especially one that's this simple, I wanted to keep it open to the most number of people. And so if I do the surface mount one, I will probably make it with 1206, which are large surface mount components, to make it easy for new people to solder themselves, and just minimize the number of wires poking through the bottom, hopefully down to 0. And although doing surface mount RJ45s is non-trivial, I keep getting a bunch of text messages that are distracting me. Anyway, I need to wrap up because I got some things I need to go do tonight. So thank you all very much for joining me on this stream. I will not be ordering tonight. I may do one more live stream where I lay out the top board. Layout is a strong term. Got to go figure out where the PTT button is going to stick through, and whether the height, the separation of those two boards means I'm going to need to do a cutout notch for the RJ45, or whether the board's going to go on top of the RJ45 where the board is just solid all the way through. So I got to go figure that out. Excuse me. But then I'm going to, and then I will be ordering boards and turning this into a kit and posting all of this. I am going to post the changes we have made. New window, CD source, OHIS, user adapter, get status, get add artwork. I'm going to put all of this into GitHub now. QR code with a link to the GitHub. So anybody who wants to play along at home can. Git add user adapt. We'll just do that. I'm going to do this off stream. Thank you all so much for joining me. I hope you had a great time. Of course, I look at the stream now, and the number of viewers has gone up. I had more viewers just a few minutes ago than... Anyway, thank you for joining me. I will be doing more of these live streams in the future. So thank you for coming up. Thanks for everyone participating in the chat room. We got Radman, KD9KCK, Ethan. I didn't see Ethan Schoonover, who tested out my QR code for me. Nerd Garage, Steve Miller, thank you very much. Kenneth Bingham, it's good to see you, Kenneth. Haven't chatted with you in a while. Steve Miller. Wait, what? Oh gosh, KC1AWV, Steve. Did you have two different YouTube accounts logged in? Okay, now I'm confused. And Amra Ahmet. So thank you all very much for joining me in the chat room, and I will catch you on the next live stream. Thank you all so much. Be good humans. Again, if you don't want to fuss with all of this stuff and you just want to throw money at the problem, then go to my website, electronics.halibut.com. I am selling the pro versions of these adapters that are finished products. They're not kits, and they have a lot more features than what I'm putting in the open source versions. Like the user adapter, the one that I sell, my User Pro, has a built-in VU meter that makes it easy for you to adjust your mic level. It also has an ability to adjust the mic level, and it's got a jumper field that allows you to create literally any combination of signals on any pins that you want. So it is a pro model of this kit that I'm designing. So if you want the more features, or if you just want to throw money at the problem, please go and do that. Otherwise, we'll get back here, and I am now getting a call, so I really need to end this stream. Thank you very much, everyone, for joining me, and I will chat with you later. This is N6MTS. Be good.